Okay, so the next problem in the lead code we are solving is to sum part 2. Okay, given that input array is sorted. Okay, so basically it's the same as the to sum part 1. Okay, but we'll try to quickly recap like I mean what we did before. You can skip this like I mean bit of video to directly go to this solution. Okay, and so what does it mean here is to sum meaning like I mean here we are given the sorted array. Okay, and also we are given the target. Okay, and what is being asked here is we'll have to find out the two elements. If we take a sum of it, we should get this target. That is this problem about. That's a two sum. That is a two sum. Okay, and now how to go about it? Like before actually going to the like currently in the two sum, right? There was no such space restriction, but in the part two, it has been given that we'll have to make use of the constant extra space. Okay, so let's see like how we did it before, and then we can see like how we can reduce the constant. We'll come to this constant extra space. Okay, you can skip the middle of the video to get directly go to the this part of the solution. Okay, let me explain how we did it for the two sum part one. Okay, so this is the problem, right? So let's say that this is a given array, and we are told that the target is 9. Okay, so what does it mean is we need to find the two numbers that will constitute the sum of the 9. Okay, so now what we'll do is we'll start with here, and let's say that we are starting from here. 2 is found. Okay, and what is the other number that will that I need to add to get a 9? Right, so like I mean that we need to find. So basically let's say that if a plus b is equal to target. Okay, a plus b is equal to target. We are given the target, and we know one number, right? We know one number, let's say that is a, and we don't know b, right? So what we can do is simply t is equal to sorry b is equal to b is equal to t minus a, correct? Like I mean so this will be the formula, right? We can just move this here. So ultimately if we apply the same thing here, so it is like 9 minus 2 7, right? What is that number that I need to add to 2 to get a 9? That's a straightforward thing. So we got to know that 7 is the number, correct? 7 is the number, and we can look in this array, correct? We can look in this array if it is found or not. So if it is found, we can return the index of this and this. That is one possible solution, right? So but it will increase the time complexity, right? Like we'll be have to iterate this array again and again. Let's say that if this number, if the given target is 17, we'll have to like I mean we'll have to come till here, right? I mean we'll have to keep on checking it. Not 17 actually, that will also be 1. So let's say that 11 plus 26. Okay, given number is 26. We'll have to come here. Okay, for every time we need to check the index of it. That will increase the time complexity. That's not a good solution. Okay, so now what we'll do is instead we'll store the occurrences. What do you mean by that is, what I mean by that is, like let's say that we have given that array, right? Let me clear that. Yeah, we have given this given this array, and that given target is 9. So what we'll do is instead of directly finding like I mean what is that element exist or not, let's do it the other way around. Okay, so I can find the other number from 7 also, right? Like I mean currently in previous example we considered 2 and we found 7, but we can also do it the other way around also, right? So what we'll do is we'll iterate from left to right, and we'll store its occurrences meaning if it was found or not. Okay, so we'll traverse from here. So let's say that 2. What is the other number that we need to, what would we need to get to the 9, right? It's a 7. Did we already visited the 7? No, right? This is the first element. We can store a dictionary actually. Like I mean, we also need an index, right? So that's why we'll store we'll maintain a dictionary, store the occurrences. And so once we got to the 2, like we'll see like if the 7 found or not. 7 is not found yet. So what we'll do is we'll update our occurrences. Like I mean, I visited this number 2, so I will update this dictionary with the index 0. Like I mean this was found at index 0. Okay, that is one thing. And now let's say that now I will go to 7, and I will do the same thing. What is the other number that is needed to get to the 9? It's a 2, correct? We need to number 2, like I mean to get to the sum 9. So what we'll do is we'll check the dictionary if it was already visited or not. Yeah, it is already visited. So what we can do is simply is we can read the value of that index, right? I mean okay, 2 is already found, so it means that is present in the list. So we can, it's a 2 sum, like I mean we found the 2 sum here. So we'll have to return the indexes of it, like I mean 0, and what is the current index? It's a 1. Like we'll have to return 0 comma 1, but it's a 1 based index, so we can start with 1, so we can just increment to 1 1, so it will be 1 comma 2. Okay, so this is how the like I mean the old approach used to work, like I mean the part 1 approach. Okay, like I mean, and also like I mean to see like I mean let's take one more example to clearly understand, right? So let's say that what we'll do is 7 11 comma 15. Okay, let's say it's a 26, target is 26. Okay, target is 26 again. We'll try to build a dictionary now again. So we'll start from the left, and like we'll store the index, of 2, and we'll store the index of 7, because we didn't find it, right? The target is not equal. So once we're 11, we'll also store 11 also. Okay, we'll also store 11 also. And ultimately when we come to 15 and try to check the other number, it will be 11, correct? 26 minus 15 will be 11. So I will check the dictionary. So 11 will be found, right? 11 will be found. I will be taking the index of it and returning it. Okay, this is how the normal two sum approach works. Okay, just another example to make it clear. Okay, and now let's see that how to improve this code such that it's a, like, I mean, space complexity should be of 1. Okay, like currently what you see, like what we saw is, like, I mean, we are maintaining this mapping, right? It just grows as the least, in the first time complexity, right? The size of the dictionary will be n elements, like it will be having the n elements. So it depends on the dictionary size, the given array size, correct? So it's not a constant space complexity. Instead it depends on the input array, correct? So what is the current problem? Like, I mean, the part 2 of the two sum is we'll have to do solve this problem without maintaining this dictionary. It means like of one time complexity we'll have to do it. Okay, so now let's see how we are going to do it. Okay, so now let's see how we are going to do it. So for this one, right, we'll make use of two pointer approach. Like, because we cannot, as we just discussed, like, I mean, in the two some part one, like we'll need a some constant dictionary. Like, I mean, will dictionary will have to maintain the occurrences. But here that can grow up to, as we know that it can grow up to of n size. That is not preferable here. So what we'll do here is we'll maintain a pointers here basically. So we'll need to take it some, right, to some. So we'll need two numbers here. We'll need to start somewhere. So let's say that will be starting from here and here. Okay, given target is same, given target is 9. Okay, given target is 9. So what we'll do is we'll take the sum of the two numbers. Left pointer is pointing to this and right pointer is pointing to this one. We will take a sum, and what it will lead to, it will give us a 17, right? 17, is it equal? If it was equal, right, we could have just returned the indexes of this. If it is not equal, okay, now what to do? So now the target sum, right, it is coming bigger than this one, right? We need to find a number which is smaller than this. And also keep in mind, this is already sorted order, right? This is in sorted order, so that is like a kind of helpful for us to find the solution easily. Okay, so 9 is the given target, but 17, this is too much, right? This is a bigger number. So what we need to do is we need a number which is lesser than this one, correct? So what we'll do is we'll have to shift our pointer to this one. So we'll try this combination now. Okay, let me just, okay, one second, let me just change the color. So we'll move our pointer to this one. Okay, so now let's do the same thing again. So let's take a sum. 11 plus 2, it will result into 13, right? It will result into 13. And also again we know that 13 is greater than 9. We'll need some number which is lesser than this, so we can shift our pointer to one more and we'll get it. So okay, and finally our right pointer is here. We'll take a sum again, 7 plus 2. It will result into the 9. That is what is the target that we are looking for, right? So in that case, what we can do is we can simply return the indexes of left and right. And as it is the start index is 1, right, we'll be have to increment by 1. Okay, so this is one case. And let's see how we can analyze the, how, like, I mean, we never discussed the how we are moving the left pointer, right? We'll see that example also. Okay, so let's take an example. Let's say let's have the same input array, but let's write a condition such that, like, I mean, left pointer will also move, right? So let's say 11, 7, and 15 will be 22, correct? Let's consider our given target is 22. Okay, or better, I guess, 18. 18 would be the correct way to explain this. Okay, so 18. Let's take the given target is 18. So our initial pointer will be at left and right, right? So what will be the initial sum? It will be 17, right? So what will get the 17, which is lesser than the this number, correct? Which is lesser than this number, correct? So what we need to do is, previously we saw that if it was more, right, it is a big number, we need to try from the next available smaller number. So we moved our right pointer by one, like, I mean, we decremented our right pointer, but here the number is getting less. We need a number which is higher than this one. Okay, so and also it's a bit higher. Let's say that if we move 15 to the next one, right, it will again give us the higher number and too much higher number, and it will result in the, again, kind of like, I mean, going behind this. So we don't want to test the right pointer here, as the number is, sum is less than the given target. So we'll move the left pointer this time. Okay, So we have moved the left pointer. So now again we'll take a sum. What will be it? 15 plus 7, 15 plus 7 will be 22. Okay, 22. Okay, this is our new target sum after moving our pointer. This is will be our current pointer, correct? And also again, if you check, this is greater than this. What we need to do when the total sum is greater than the current one, we'll have to decrement our right pointer. So the next pointer it will be moving to here. Okay, and now if you take the sum, right, so 11 plus 7, it will be 18. That will be equal, so we'll have to return the values that are indices of this one by plus 1, considering that the start index is 1. Okay, so that is it, like how we used to solve this to some part 1, and now it is part 2 with the constant space complexity. Okay, now quickly check the solution. If you have understood the problem, I think there is not much, nothing much here to understand. So what we done is, like, I mean, length of numbers. Okay, like, I mean, we are setting the pointer initially to 0 and to the end. Okay, and now we'll have to break the breakout of the loop when we are not able to find out any condition. It is being given that it is always found, but let's have that condition like left is less than right, and if not found, we'll be returning minus 1 comma minus 1. Okay, and now, like, we'll be taking the total, and based on that, if we found the target, it is equal to the target, we'll be returning the left or right pointer indices. And if it is lesser than that, we'll be incrementing our left pointer, and if it is greater, it means that total has become a little big, we need a less number that is next to it, so we'll be reducing our right pointer. Yeah, that is it. This is the previous approach. We can see that we'll be iterating through it. We'll check if the complaint was already visited or not. If it is not visited, we'll update it. Once we visit it, we'll be maintaining that, if we will be updating that mapper. Okay, like occurrences dictionary, we'll be using that to get the final result. Yeah, that's it. After this video explains, like, I mean, both the approaches. Yeah, thanks.